And get my coat off here. Good Sunday afternoon. How are you doing out there? It's a cold, cold, cold weekend. Really is a big setback compared to the nice weather that we did have. So I'm running the Mr. Heater. It's super cold in here. Not right now, but when I first come in, I had the heater running for about 15 minutes right now on high. And it's getting comfortable in here. I got this a little, you may not be able to see it from the camera angle here. I got my little 250 watt heater that's normally running all the time. I got it on the bench here, and of course it shuts off when you pick it up. It's got the safety switch on it. And I got it here because everything here is cold. I mean, you know, ice cold. And I haven't done any more on this receiver since the last video that I made. I just have not been in the shop. It's just been too damn cold. Couple of things I want to show you here, and I'm trying to keep the video short, but with me, that's not possible. I have a question for you guys out there that work on computers. I have this Muffin fan that I pulled out of an old Dell that I got at a yard sale a year or so ago. Can't remember the number now, 620 or something like that. It's that one that had all the bad caps in it. Well, one of my viewers, as a matter of fact, it was Steve, wanted the processor out of it, so I was happy to send it to him. He was the one that sent me this communication receiver. I sent him that and a CD drive from that computer, but I saved the fan, and it's a, I think it's a 4-inch fan, and it's 12 volts, okay? And what I was going to use it for is, in the summertime, I want to put it up against one of those screen, let me show you. Actually, this one here, I don't know, it looks a little dark in there. All right, I may not be in focus because I'm on landscape, but I think you'll be able to see what I'm doing. I want to mount it right here. It fits perfectly over that as an exhaust, to pull out the exhaust, and primarily in the summertime to get the humidity out and everything. Right now I can feel a little cool air coming in. There's some air circulation, but I don't mind that. It's very, very faint. But I want to use it as an exhaust fan. But let me get this thing on the close-up here, and I'll show you what the question is that I want to ask. Okay, it's a 12-volt fan, and you may not be able to see it, but there is some sort of some kind of circuitry in here. I was looking at 12-volt vids, and I can't remember what video it was, and he put a fan in one of his televisions, the flat screens he was working on, and at that time, I don't remember what video, but anyways, I need to know what the positive and negative is of the 12 volts. There are 4 wires on this. There's a yellow, a black, a blue, and a red. I would assume the black and red would be the 12 volts, but I'm not 100% sure. So, if anybody knows, because I want to put a 12 volt wall wart on this and have it switched in as an exhaust fan in the summertime. So that's why I'm saving this fan here. I'll put this through the magnifier. I'm using the Kodak Play Touch, but I'm pretty sure you can see the thing pretty good the way it is. But you can see I got the 4 wires here. Anybody know where the 12 volts would be? I mean, I could gamble it and put 12 volts on the red and black, but there's no guarantee I'm going to blow this thing up putting it through the wrong coil on the motor. I'm not sure how these things work. It's supposed to be a speed sensor or something when it's in the computer, and that's what the other 2 wires are for, but I have no idea. That's not my department. I don't know too much about it. Every Muffin fan I have ever seen always had just 2 wires on it. And they usually run at 120 volts, or if they run on 12 volts, there's usually only 2 wires. So if anybody has any answers to that, I'd appreciate it, because I need to use this for an exhaust fan. Alright, so I got my electric heater pointed the other way here so I can get you. You're probably noticing something on the bench here. I got this off of one of the fellows on the Antique Radio Forum. I've been looking for a Simpson 260. I don't have a good analog meter other than this Motorola here, but this Motorola, you can't get any information on it, by the way. There is no information whatsoever on it. I did a video a long time ago. This is all transistorized, so I'm assuming that this is not a VOM type of meter. In other words, it's not 20,000 ohms per volt. It's more like a VTVM. It works very well. Matter of fact, I ran through its paces, and I made some adjustments, and she's right on. So it works very well. But it is portable. It's battery operated. But that's a battery test, by the way. My problem was I was using these things. I have 2 of them. One I got at a yard sale last year for $1. And this one I've had for many years, and it takes 1 AA and it keeps on losing connection inside, and it keeps going dead on me on ohms, and the battery's good. So I'm getting tired of reading a tiny scale, trying to see what I'm doing. So I had the chance of buying this Simpson 260 Series 8. Don't know if you can see that down there. And the fellow sold it to me with the leads. I didn't know the different series Simpsons used different kinds of plugs. And what the Simpson Series 8 uses is, I've never heard of them before until I asked some questions, what they call the inverted banana jacks, the plugs. So this jack here is just the opposite of what would be in my Fluke 73 digital multimeter and most other multimeters. The male is in here and the female is here. It's just the opposite on the regular ones. So this one came with the leads. So the guy was nice enough to send me the leads. It works very good. It came with the batteries. The only thing that it did not have is the screws are missing. There are 2 screws under the battery cover and 2 screws down at the bottom, and they were missing. So he tied it with a cable tie, and there's no need to open this up. If you need to get the batteries, you just loosen that 1 screw on the top, and you got a D cell and a 9-volt battery. Now, this works very well. I checked it using my Fluke 73 digital multimeter and the Simpson 260 connected together, running from 0 to 18.5 volts, which is what this power supply puts out. It's right on, as close as I can read it. Then I went to the higher voltage range with the Telemic T05, and it read all the way up right on the money, as close as I can read it. So the DC ranges on that Simpson 260 is right on. Now, you may ask, why would I need a analog meter when I have this, which, by the way, reads right on the money, except for the AC ranges below 50 volts, as I mentioned. And the biggest problem was my test leads on low ohm resistance, which we already went through on a video, and we know what that problem is. Well, when you're testing resistors in circuit, sometimes a resistor will read higher, believe this or not, because it's in circuit and it's influenced by capacitors that are in circuit. And the only way you can eliminate the problem is using a low impedance meter. This is 20,000 ohms per volt, whereas your digital multimeters are 10 and 11 megohms input impedance. Now, if you, I learned this, I know the influence of capacitors and other things in the circuit would give you some screwy readings, and I was not aware of, it never made any sense. Let's say you've got a 100,000 ohm resistor and it's reading into the megohm range because it's in circuit. You disconnect it, one end of it, and she'll read, let's say, for instance now, 100,000 ohms, she'll read that. But if you use an analog meter, you'll get the reading, unless the resistor is loaded down with other resistors, she'll read right on. If you do not believe me, check out the radio mechanic. He found out the hard way. He has a very good video out there on that subject of using a digital meter can really drive you up the wall checking for resistors in circuit. Whereas you use a good old VOM and you're much better. You'll get the accurate readings because the VOMs are not influenced by the capacitors. Naturally, you've got to discharge the capacitors. That goes without saying. So please check out the radio mechanic. Offhand, I don't know what the video is called, but it's not too old, so you should be able to find it. Okay, there's only one thing I do not like about the Simpson, and I think they're all the same. As far as resistance is concerned, they're right on. It's very accurate, as close as I can tell. It only goes up to R times 10,000. According to the specifications, this is supposed to read 20 megohms, which is impossible. Here is 10 meg, 5%. Got it on there. Got the leads on. You're not even seeing it on the meter. And the meter is on. And we'll zero the leads. Alright, so she's still right on 0. I didn't change the range on R times 10,000. So this will not read anything accurately over 1 meg. Anything beyond 1 meg, you're getting cramped in this area, and this thing isn't even moving. 10 meg is cramped in there so bad, it's physically impossible to see anything. So it's useless above 1 megohm. So, I got a Simpson because everybody raves about them, and I bought it so that I can check resistors in circuit without being influenced by crazy readings on a digital multimeter. Now, the radio mechanic uses a a triplet 630, he seems to get those at bargain basement prices. You can't touch a triplet 630 for less than $100. And some of those aren't even working. They're as is for parts only. I paid $40 for this, plus about $12 or $13 for shipping. It was a very good deal. I can't complain about that. It left me totally strapped for the week. As a matter of fact, for a couple of weeks. But, you know, it takes an investment to get your shop up to what you want it to be. Now, these are very handy. I mean, I'm glad I got it. It's just that, you know, the range, you can't test anything, regardless of what the specs say. It's pretty useless above 1 megohm. Now, that sounds pretty bad. Unless I'm missing something here. I read the book over and over, and you're supposed to use the plus and minus jacks here for resistance. And the control here is plus or minus, and that just reverses the polarity on this. So if you're checking semiconductors, you know, you can reverse it. And then, of course, you've got your own AC scale, if you're reading AC. And this will read up to 1,000 volts. And I got 660 volts off of my T05 Sprague telemic. So I had to use the 1,000 volt jack. So everything's working good. The complaint is anything over 1 meg, you're just not going to, you can't see it. I can take the clip off now. I'm going to lift the clip off of the meter, off of this. It's on 1 resistor only. I'm going to take the clip off, and you take a good look at the meter, and you'll see very little movement when I lift it off. It hardly moved. It went to infinity. I'll put it on, but I probably won't get a good connection because I'm doing this one-handed. I can't mount this camera in my camera boom. I have to redesign that whole thing. So I'm back to hand holding. Now I'm going to put the resistor back on, the 10 megohm. Barely moves. Take it off. Put it on. Take it off. Put it on. Okay, so put it back on volts. Always put your meter back on volts. It has an off switch. Turn it off. Otherwise, it's an excellent meter. But Simpson 260s, to my knowledge, won't read anything. Not even 10 megs. Now, maybe some models do. I thought, you know, being a Series 8, I knew nothing about the series. I'm learning this as I go along. I've never owned a Simpson 260 in my life. I did have a Simpson 270 back many years ago in my old shop. That was a basket case that was in the dumpster because the case was completely crushed and it was held together with black electrical tape, but the meter worked good. I got rid of that. I don't know. I get rid of things I should have kept, but at the time, you know, I figured I'd never use it. And I ended up using a Micronta large-scale 50,000 ohm per volt meter, which I think had 43 ranges. I don't know the number of it. That was a very good meter too, and that got destroyed by an ironworker friend of mine who was working on his car with it and slammed the damn hood down on the meter and busted it. But I wasn't about to argue with the guy. I think you know who, you've seen him when he was building his house out of oak. But that was back in the 70s. No, the man's gone. Let him rest in peace. He died years ago. But anyways, so I just figured I'd make this video and show you that, you know, I do have a new addition to my shop, and I am very happy with it. But at least I can test resistors below 1 megohm in circuit and not be influenced by capacitors. Another thing you always do, and I'm going to repeat again, make sure your capacitors are discharged before doing any work on any equipment, whether you're measuring voltage or resistance. And for the sake of the meter also, you don't want to ruin an ohm meter by having capacitors that are charged still in your equipment. So a good thing to do is to take a clip lead and short out your electrolytics. Make sure you take them off when you power it up again, and then do your ohm checks. If you don't want to cut them out of circuit, because I don't like cutting things out of circuit because I have to tack them back in because I can't do them any other way because of my eyesight. All right, folks. I want to touch on one other thing about the Simpson meters, and I'm trying to share knowledge with you, that stuff that I just learned. And a lot of you fellas out there may not even know that the series of Simpson 260s, not all of them use standard plugs. Like the ones that are on my Fluke 73, for instance, and on most multimeters, is a male at this end and a female at this end. It is just the opposite on that, and they call them inverted banana plugs or jacks. I never heard of the term before, and I asked, and I kind of felt stupid because what the hell? I mean, let me make sure I'm putting this back in the right hole. Ohms and volts, okay. I don't want to put it in here. That's for the 10 amp range, and you don't want to put measuring voltage in the 10 amp range or you ruin it. But anyways, so I can't use these leads on this. Now these are nice heavy leads. What you want on test leads is 18 gauge wire. You don't want anything lower than that. You want stranded wire. My good buddy Doug there mistakenly ordered solid wire. It's just going to break off on him, and it's going to be awkward. It's going to be stiff and hard to work with, and could even pull your meter down off the bench, you know, if you get hooked on it. That's what I worry about on the Simpson. It's a Bakelite case, and if that falls on the floor, that's goodbye case. You know, they're very, they're not made to be dropped. And this one's going to stay on the bench, but you don't want leads that are so stiff they're going to pull the meter all over the bench. But anyways, so you got to make sure the Series 8 uses what they call the inverted banana plugs. And the part number, I think, is 00043 or 0043. You can get them. They're very hard to get. And you will not get them for less than $40 a set and up. Believe me, I've checked. So I was not aware of that, because I've been looking for Simpson 260s on eBay, and there's all kinds of series. Now, suppose I bought one from eBay. Most of them don't come with the leads, and I didn't get the leads, and I'd have to spend $40 to $50. I've seen them as high as $55 for a set of test leads for a Simpson 260. That would be a real heartbreak, wouldn't it? So do your research, because I didn't. I found out the hard way. After I got this, he was nice enough to send me the leads because he told me he had the leads with it. But you may not be so lucky. So once you pay a big sum of money for a Simpson 260, and then you have to turn around and spend that or more for a set of test leads, that's ridiculous. When this meter come out, it's a $300 meter. Like I say, I paid $40 plus $13.60, I think, for shipping. Priority mail. So I appreciate that. The fellow's name is Chuck that sent it to me. And I don't know if he's one of my viewers or not, but he did reply to my posting as to looking for a good quality VOM. And I really wanted to get the triplet 630, but they are way out of my price range, and I think the resistance reads higher. I think it's 100 R times 100,000. This only goes to R times 10,000, which, as you can see, is pretty useless beyond 1 meg. Not 10 meg, 1 meg. 10 meg wouldn't even hardly move the needle, as I proved in this video. So I'm sharing what I'm learning with you people, and that's the purpose of my videos. A lot of my videos, I'm looking at the clock here. I've got to get going very soon here. So I'm going to turn the heat off now. I try to help everybody out, and if I learn something, I like to pass it on to everyone else. So it's not easy. I see something, or I have an opportunity to buy something, and even if I don't have enough cash on me, I leave myself short. I have a budget amount of money that I can spend each week. And I'm always leaving myself down to about $20 for the whole damn week after I go and buy something like this. And once I get equipped, and I'm pretty well equipped, I'll say. The only thing I don't have is an ESR meter. I'm not going to worry about it, because I'm doing vintage stuff, and you just replace the capacitors anyways. If I was doing solid state stuff, yeah, I would need an ESR meter. If I was doing flat screen TVs and stuff, I can't even see the holes in the circuit board to solder them. On this meter here, there was a 4,700 microfarad. It's over here, the old one. Here it is. I replaced. It took me a half an hour to unsolder, to clear the holes. I got this out, no problem. It's a 16 volt, 4,700 microfarad. It's a JAMICON capacitor that was in the main power supply of this B&K Precision. I have to keep wanting to say HP. It's a B&K Precision meter, because I thought there was something wrong because it was reading high in the ohms, but we found out it's the test leads. So I had a 4,700 microfarad 50 volt electrolytic, brand new in stock, and I replaced it with that. And it took me a half an hour to clear the damn holes out to get the new one in. Solder wick is useless. Completely useless. I used to use it years ago, and it never worked right for me. I do the old-fashioned way. I use the bulb right here. I got that plunger thing, solder thing. That's useless. I got to put away. That don't work. The old bulb works the best, and heating up the board and going, blowing the holes clear with my mouth. So I have no luck. It took me a long time to get the new capacitor to go, the leads to go through the holes. What a hell of a job. I can't work with that stuff. It's too damn small. That's why I hook and pinch, because it's the only way I can do it. The leads hang there, and I can't see to pinch them over tight like I used to do years ago, so it'll make a good rigid connection, because the capacitor is hanging like this, because I need to hold this, I need to hold the needle nose, and, you know, it's just like I need 10 hands, you know. We went through this already before, so I don't need an ESR meter. Don't need it. On vintage equipment, we just replace the electrolytics anyway, so you don't need it. And that's why I bought the Telemic, because it'll read on the high capacity, whereas the ICO 950 expanded scale will not work. So anything over 50 microfarads, it's useless on the ICO. Whereas the TO5 Telemic will read up to 2,000 microfarads. So anything over 2,000 I'm not even worried about anyways, because usually those capacitors are all low voltage. And if you are familiar with the Sprague Telemic series, there's like about 85 volts on the electrolytic. So you don't want to put a low voltage electrolytic in the Sprague Telemic. You don't want to do it on the ICO 950 either because there's about 43 volts on the bridge circuit for that. I measured all these. Okay, thank you very much for watching. I hope this video was of some help to you. And we'll catch you on a video on your computer, in your room, or in wherever you have your computer very soon. Have a good day, good night, good evening, good morning, good year, good month, or whatever. Thanks for watching.